Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and in this video we're going to be implementing the player's death animation. So the first thing that we're going to do is go to the player.h and add a few more variables that add more functionality to this class. We will first include the audio manager so that we can play the explosion sound. So we'll include audio manager.h, and then over here we will add an audio manager pointer. We'll call this one M-Audio. And then next up we will add our animated texture for the player death, the death animation. So we will do an animated texture pointer. We'll call this one M-Death Animation. And then we will just need one more function down here. And this one will be called void was hit. And this will be called by the level whenever there's a collision between the player and another entity. So either an enemy or an enemy bullet. So now that we have everything in the .h that we need, we can go to the player.cpp and start implementing these. So we'll go to the player constructor and say that M-Audio is going to be equal to an audio manager instance. And we will go down here and set it to null in the destructor. And then next up, we will initialize the death animation. So for the death animation, we need to say that mDeath animation is going to be equal to a new animated texture. And this animated texture will be a texture that I created here. So I have a texture right here of the 4 frames of the ship's explosion for the player. And each one of these frames is the same size. So if it's a bit too big, I just have it centered and I have empty space around it. The width of each frame is 125 pixels and the height is 128. So if you made a different size texture, you can change those to whichever texture size that you have. And this one is called player exp.png. So in here, we'll say player exp.png. Our x and y, it's starting from 0 and 0, so I can set that to 0 and 0. Next up is our width, and the width for each frame is going to be 125. The height for each frame will be 128. The frame count is 4. The animation speed, I'll set it to 1 second. And finally, the direction is horizontal. So animated texture horizontal. And this will be it for initializing that class. Next up, I will add it as a child of the player. So death animation parent is this. And then the death animation position is going to be zeroed out. So vector to 0. Now, the last thing that I need to do for this death animation to make it not loop and only play once. So I'll say mDeath animation wrap mode is going to be animated texture once. And this should be it for initializing our death animation. So over here in the destructor, I will delete it. So delete mDeath animation. And mDeath animation is going to be equal to null. And that will be it for our constructor and destructor. Next up, we will implement this function that we just added, which is was hit. For was hit, we will go down to right before the update and say that void player was hit. And our lives are going to be decreased by 1, so mLives minus minus. M-animating is going to be equal to true. And then our M-audio is going to play a sound effect. And I have a sound effect here, which is called player destroyed.wave. And this is just the sound of the player explosion. And by the way, I have the animation set to 1 second because my explosion sound is 1 second long. So this is player destroyed.wave, so I need to just pass it in here. Player destroyed.wave. Now, there is a problem with our animated texture class, which is that if we're playing only once, we have no way to actually know when the animation ended. So we will go to our animated texture.h and we will add that functionality to it. So if we open up animated texture.h, right underneath wrap mode, we will add two extra functions. One will be void reset animation, and for an animation that only runs once, it's pretty helpful to actually add a reset animation so we can play it over and over again whenever we need to. So we will have that, and the next one will be a boolean is animating, and this will always return true if the wrap mode is loop, but if it's once, we would return true once the animation is animating, would be false once the animation is done. So we can go now to our animated texture.cpp, and right here underneath or above update, we can say void animated texture, and we have it called reset animation. And the reset animation, all we'll do is reset the timer back to 0. So m animation timer is going to be 0.0f, and m animation done is going to be equal to false. And that will be it for that function. Next up is animating. So we will do a boolean animated texture is animating, and we already have a way to keep track of whether the animation is done or not in our m animation done. But is animating needs to return the negative of whatever animation done is. So we'll return a not m animation done. And this not will just make it so that if the animation is done, is animating will be false. If the animation is not done, is animating would be true. And this should be it for our animated texture.cpp. Now we can go back to our player.cpp, and after we subtract the lives, we can just reset the player's death animation. So m death animation reset animation. And this will be it for our was hit function. Now the last thing that we need to do is to go down here and fill out the animating section of the update and the render. So over here we will do m death animation update as long as we're animating, and then m animating is going to be equal to our death animation is animating. So once is animating is false, this will be false, and then we can go back to handling the movement. Next up in our render, we can then just render our death animation. So we'll say m death animation render, and that will be it for the player class. Now that we have this set up, we can move on to the level, and the level will handle on the collision detection. So the level will be the one to call the was hit function in the player. But for now, we will not actually do any collisions. We're gonna add a function and tell it if we press a certain key, tell the player he was just hit. So if we go to our level.h, we'll add a few more variables in here. So the first variable will be right underneath player. We'll do a boolean m player hit, and this will be true whenever the player gets hit by an enemy or an enemy bullet. We will have a float m player respawn delay, and this is how long the player waits for to respawn after he's destroyed. This is also the respawn delay is also after the player the explosion animation is done. And then float m player respawn timer, and a float respawn label on screen. Now the timer is pretty straightforward, it just increments and waits for the delay. But for the respawn label, or m respawn label on screen, for this one will be the ready label so that we can show it again before the player is respawned. So now that we have all these three, we also need a game over label. So over here, we will do a texture pointer, game over label, a boolean game over. So game over will be true if the player runs out of lives. So if the player didn't run out of lives, we can just do a respawn delay and respawn the player. But if the player runs out of lives, we need to let the play screen know that the game is over. So this is why we have these variables here. Next up is a float game over delay and a float game over timer. Then finally a float game over label on screen, which is pretty much the same idea as the respawn. Now, the last thing that we need to do is to add an enum that can keep track of the state of the level. So if the level is finished, or it's game over, or if the level is still running. So up here, we'll do a public, and we'll do an enum level underscore states. And this will have three different states: running, finished, and game over. So finished will be true if all the enemies are destroyed, and then game over will be true if the player runs out of lives. So we can go down here and declare some of our functions that we need. We will need a few private functions to deal with some of the behaviors that we have in the level. So the first one will be void handle start labels. We will move some of the stuff in the update into that one to show the stage and ready and all that stuff. And then void handle collisions and void handle player death. So these are the three private functions that we'll need. Finally, we will need one public function which is gonna return the state of the level. So level underscore states, state, and this will return our state. So since we have our state, we need to keep track of it. So up here in our variables, we will do a level underscore states current state. And that will be it for our level.cpp or level.h. Now we can go to our level.cpp and declare or implement some of the stuff that we just added. So in level.cpp, what do we have here? We have our player hit, player respawn delay, and the player timer, and the player respawn label on screen. So let's start with these. We will go to where the player is, and right underneath the player, we'll say that our player hit is going to start off being false. Player respawn delay is going to be equal to 3.0f, and player respawn timer is going to start off at 0.0f. So we want to wait for 3 seconds before we respawn the player again, and these 3 seconds, keep in mind, this is after the animation, the explosion animation is done. And then finally, respawn label on screen, and respawn label on screen is how long we want to wait until we show ready on screen. So after the player is destroyed, we want to wait for 2 seconds and then show ready for 1 second, and then it disappears. So it's gonna start off at 2. So when the timer is counting, once it hits 2, show the ready label, and then at 3, the ready label is gonna disappear, and then we're gonna show the player again. Now to move on, we will have our game over label. So game over label is going to be equal to a new texture, and this one will say game over. Our font will be emulogic.ttf. The size will be 32 as usual, and the color will be 150, 0, and 0. Now game over label parent is going to be this, and game over label position, we will have the game over position the same as the ready label position. So we'll just copy what we have for the label position and paste it into the game over position. And that will be it for our label. Now we need to clear it. So over here in the destructor, we'll say delete m game over label. And our m game over label is going to be equal to null. Then the final thing that we need to do is to initialize these variables right here. So our game over is going to start off being false. So we'll go down here. M game over is going to be false. And then m game over delay is going to be equal to 6.0f. So we want to wait for 6 seconds before we move on to either the start screen or whatever else that we have. We're going to add a score screen later on, but for now we're going to go back to the start screen. So wait for 6 seconds and then go back to the start screen. M game over timer is going to start off being 0.0f, and then m game over label on screen is going to be equal to, so we want to show the game over label for 5 seconds, but we want to wait for 1 second before we start showing it. So this will be starting off at 1.0f. And then finally, the last thing is our current state. So m current state is going to be equal to running. And that will be it for our constructor and destructor. Now we can implement some of these functions that we added. So we already have the start stage function, so that's fine. So we need to add the handle start labels. So underneath start stage, we'll do void level handle start labels. And for handle start labels, it will be pretty straightforward. Just copy everything inside the stage not started, and we'll paste it right in here. That will just make it a little bit more tidy. And then we'll say that if the stage hasn't started yet, handle start labels. And that should be it for that. It's just so that we can keep our update from getting cluttered. And then in the update, so if the stage hasn't started, handle the start labels. Otherwise, so else, we can handle the other things that we need to deal with. And the other things that we're going to be dealing with is, first off, is handling the collisions. So we'll say handle collisions. And then we will implement our handle collisions function right here. So for handle collisions, we'll say void level handle collisions. And then in here, we'll say that if the player hasn't been hit, so if the player is not hit, if not player hit, in here we'll be checking for collisions. But since we don't have collisions yet, we can set a key to get the player, to tell the player that they were just hit. So if input manager instance key pressed SDL underscore scan code underscore, we'll say X. So if the X key is pressed, we'll tell the player that they were just hit. So we'll say mPlayer was hit. And then we will update the sidebar's ship. So we'll say mSidebar set ships, and set ships will return the player lives. So mPlayer lives. Now, next up, since the player was just hit, we'll set mPlayer hit to true. So mPlayer hit is equal to true. And mPlayer respawn timer is going to be equal to 0.0f. We will tell the player that they are now no longer active, so that the player can't move around. So player active to false. And we will stop scrolling the stars. So mStars scroll to false. And this will be it for when the player is hit. Now when we implement our collision, all we need to do is to, instead of have this if statement, we'll just call this one whenever a collision happens with the player. Now that we have this, in our update we're already handling the collisions. So the next thing that we can do is to handle, what do we have next? Is to handle the player's death. So right underneath the handle collisions, we'll do a void level handle player death. And in here, we'll check if the player is done animating or not. So the first thing that we're going to do is to say that if the player is not animating, so if not mPlayer is animating, so if the player is currently not animating and the player has been hit, that means that the explosion animation is done playing. And once the explosion animation is done playing, we can either decide to respawn the player if he has lives, or we can say game over if he doesn't. And this is the whole idea behind this one, because in our update, we're only going to call this function, the handle player death, when the player was hit. So we will say, for example, in update, right underneath handle collision, we'll say that if mPlayer hit, so if the player was hit, handle the player's death. So this will only be called whenever the player has been hit and the animation is no longer playing. So first we need to check whether the player still has lives or not. So we can say if mPlayer lives is more than 0, so the player still has lives, we have to respawn the player. So we'll say that if the player timer is more than 0, or no, if the player timer is equal to 0.0f, so on the first time it comes through here, we want to disable the player because the explosion animation is done. We want to make the player disappear for a while so that we can show the ready label and then make him appear right after. So we'll make him disappear for now. We'll say mPlayer visible is false. So now the player disappeared, and start incrementing the respawn timer. So mPlayer respawn timer plus equals the timer delta time. And then if the player respawn timer is more than or equal to the respawn delay, so mPlayer respawn delay, we can now respawn the player again. So we'll say mPlayer active to true, mPlayer visible to true, mPlayer hit is going to be false because the player is no longer hit, and we need to start scrolling the stars again. So mStars scroll back to true. So if the player still has lives, just respawn the player. And this will be it for respawning the player if the player has been hit. Now, if we go down to our renderer, what we need to do is to handle the labels that we need to show. And for that, we will do an else for the stage started. So if the stage hasn't started, we're dealing with these labels. Else, we need to deal with the player's respawn labels and the game over label. So we can say if the player was hit, and then if the player respawn timer is more than or equal to the respawn label on screen, so the player respawn what did I call it here? Oh, probably we need to call it player respawn label on screen. So yeah, so just to keep it consistent with everything else, so mPlayer respawn label on screen. It's a mouthful, but at least it's descriptive. So mPlayer, if the player respawn timer is more than or equal to the player respawn label on screen, that's probably going to be, it's going to be complaining about it up here, so we'll probably have to change that. So the player respawn label on screen is 2. So we'll go back down to our render, and in here we'll say, as long as this is the case, ready label render. So we are rendering the ready label. So now we have a way to destroy the player. And when the player is destroyed, he should play the death animation. And when the death animation is played, once the death animation is over, we should have another player respawn. So let's try to run it and see what happens. So there we go. So that's started, we have ready, and then when we press X, let's see. There we go. So the player disappeared, we have ready, and then we have our player again. We press X again. The player is dead this time, but then the player reappears because we haven't put an enemy functionality for a game over, because the player lost all his lives. But for now, the player respawning seems to be working well. Now, we just need to add the game over functionality. And for this, we will go up to our handle player death, and we need to add an else for the player lives that are more than 0. So else the player lives are equal to 0, we need to handle the game over. So we'll say that if the game over timer, pretty much the same idea here, if the game over timer is equal to 0.0f, it's our first time going through this, we want the player to be invisible. So mPlayer visible to false, and then increment the game over timer. So game over timer plus equals the mTimer delta time. And then if the game over timer is more than or equal to the game over delay, all we need to do is just set our current state to game over. So current state is going to be equal to game over. And that will be it for this part. Now we need to go to our update and deal with the game over handling, or actually in the render. So in the render, in the game over handling, we need to deal with rendering the game over label. So we'll say if game over timer is more than or equal to the game over label on screen, game over label render. And that will be it for the game over functionality. So let's see if it works. Hopefully it does. There we go. So we have our 2 lives. Press X. That's 1 life gone. Respawn the player, and the stars should start scrolling again. Press X again, and then the player is dead. And then we're showing game over on the screen. And then game over is going to stay on the screen because we're not doing anything else. So now we just need to go back to our start screen from the play screen. So this should be it for that. This part is kind of bothering me, but this should be it for this part. So now we need to add the functionality for the play screen to take us back if the game is over. Actually, what we can also do is move the next level functionality into our level. So we can set the level to finished when we press a key instead of doing it in the play screen. So what we can do here is go into our update, and over here we can say if the input manager instance, so this is right underneath our player hit handle player death, key pressed SDL scan code underscore n. So for a new level, we can just say current state equals finished. And that will be it. So now if we go back to our playscreen.cpp, we probably in update, we don't need this whole scan code N thing, so we can remove it from here. And we can go to our play screen and start setting up our we can start setting up the whole thing so that it can take us back. And for that, we will need one more function in our play screen. And this function will be a public, and it's right on above the update. We can do a boolean m game over, or probably not m, boolean game over. And this is the only function that we're going to need in our play screen for now. So in play screen.cpp, game over, what it will do is, so over here, right above update, we can say void player or play screen game over. So play screen game over, we need to, if the level hasn't started yet, we need to return false, because there's no game over if we don't have a level. So if not m level started, return false. Otherwise, so if the level has started, oh, this needs to be a boolean. If the level has started, we need to return m level state is going to be equal to level game over. So if the level state is game over, return true, otherwise return false. And now if we go back to our screen manager.cpp, we can tell the screen manager in our screen manager update, we can tell it that, so instead of escape, we can remove that, and we're updating the play screen. So over here we can say if the play screen game over, so if it's game over, the current screen is going to be equal to start. So instead of pressing escape to go back to the start screen from the play screen, now we only go back if it's game over. And that should be the changes that we need for the screen manager. Now in the play screen, we can go down to, so what do we have here? So we have our play screen, but what we need to do is check whether the level state is finished or not. So over here, we need to add brackets for this, for the level started. And inside here, we're updating the level. We need to check if the level is finished or not. So we can say if m level state is equal to level finished. So level finished is going to be true if all the enemies are killed in the level. So we'll say m level started is going to be equal to false. So it's the same idea, but instead of pressing N to do that, we are using the level itself is the one that's telling the play screen that the level is finished. And that should be it for this part. So what we can do is run it and see how it goes. Okay. Right, we did not implement state. So in our level.cpp, we need to implement state. So right above update, we can do level states, or this is going to be level states, and this will be level state. This one will just return current state. And that will be it for this one. So that's in level.cpp. We're just implementing our state function. So let's try to run it again and see how it goes. So enter. So we are ready, and then press X. The player died once. We still have one life, so ready, and the player dies again. And then we get our game over screen. We should stay for about 6 seconds. And then after 6 seconds is over, we go back to the start screen. And then if we press enter, it did not reset. So we need to fix that. So what we need to do is to go to our play screen .cpp, so playscreen.cpp, and what we need to fix is a few things in our start new game, because we're not resetting everything in start new game, and that's what we need to do now. So over here we are setting the starts to false, so that's fine. We are setting all these things to what they should be. And then what we need to do is to set, so we have our game started, we need to set our level started as well to false, and our M level start timer to 0.0f. And then we have our current stage to 0, and the start music is playing. So now let's see if this changes anything. So we have our level again, press enter. Now we press X to kill the player. And press X again. And then we get our game over screen, and then we're sent back to the start screen. So if we press enter again, and we're back to a new level. And there is one thing that's not working correctly here, which is this flag. I just noticed it now, is that if this is destroyed, and then it's destroyed again, we come back and the flag is there. So let's see how we can fix that. Maybe if we set the level to 0. So let's see here. So now over here we have all this. The sidebar, the lives are being set to this. So what we can do is we will probably need to clear all the flags. So let's see here. Oh, not this one. Set level to 0. And let's see what happens now. So we kill the player once. We kill the player again. And then the flag is gone. And then it should reappear again once the stage is counted. There we go. So this seems to be working. All I did was just set the sidebar's level back to 0 in our start new game so that it clears all the flags from there so that we can show the flags again. Now let's see if our N works. So if we press N, now that's stage 2, and again, that's stage 3, and it only works if the level is started. So if we press again, that's stage 4. Let's see if it works if the player is destroyed. There we go, and then the player is killed. So that is a bug that we need to fix. So if N is pressed, it sets the level to finished before, even though the player is dead. So we probably need to fix that. So what we need to do is over here, we can tell it if the player is not hit. So else, only do that if the player was not hit. So we can probably add the brackets for these as well. There we go. So if the player is hit, handle the player's death. Otherwise, if N is pressed, finish the level. So now if we run it, that should stop that bug from happening. There we go. So it only does that now. It only increments the level if the player is on screen and the player is not animating at all. Okay, and this will be all the functionality that we need to add more things to the game. So now we have a way to increment the levels, to tell the play screen that the level is done, to switch to the next screen. We have a way to kill the player and respawn him, and we have a way to know when the game is over, so that we now go back to the start screen, or we can go to the scoreboard and show the player the high score. And that will be it for this video. I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.